So Unit 5, Lesson 7, Cosine Law Review and 3D Problems. So prior we looked at sine law, and basically sine law said that take a look at your angle and your corresponding side, angle and your corresponding side, and using that relationship you can either find the angle or the side depending on what you need. For cosine law, it works a little differently, and the equations that you have for cosine law is c squared equals a squared plus b squared minus 2ab cos c. The other version of it is that you have, it's just isolating for cos c, and cos c is equal to a squared plus b squared minus c squared divided by 2ab. So if you take a look at the things that you need in order to solve for c, you have a side, and you have an angle. So let's take a look at it in terms of a triangle. So it's kind of very specific on what you're given, and so you have to be given a side, angle, side, and it has to be in that order. So for example, if you have a side and this angle and this side, that is not a true side angle side because the order matters, and it matters that it's the sides that are kind of umbrellaing or sheltering in this angle. And by solving for these, you are finding the other side. And I just wrote that, remember, with this equation, you can write it the other way, and that's why we have the other version. And for the other version, we're dealing with a triangle, and it can be any kind of triangle. It could be a right angle triangle. It doesn't have to be a right angle triangle. So remember the flow chart that I referred to in the previous lesson. And so in this case, what you see inside is that you have a side, and a side. And so let's say you have these three sides. Well, you are solving for, let's say, this angle. And notice that the part that you're taking away, the minus c squared, so that's the side that you're taking away so that you can find the angle that is corresponding to it. And so you're using the cosine law in two situations: when you have sine, angle, side in this order, or when you have side, side, and you're finding for a certain angle. So question 2, solve each triangle. This means find all sides, all angles. The thing about when you're doing any math problem, we're conveniently under the cosine law, so we're probably going to use cosine law, but the mental check you need to do is this the right angle triangle? Because it's not a right angle triangle, I am not going to be able to do SOHCAHTOA. I can't do Pythagorean theorem. Therefore, I'm going to have to rely on sine law or cosine law, and that's based on the pathway, which is over there. And so I am going to have to take a look at this triangle and identify that I have a side, angle, a side. So that means I do have to use this cosine law, and that's how you break down a problem, okay? So as an FYI, so for this side, the corresponding angle is this. For this side, the corresponding angle is this. Notice that I don't really have the corresponding pairs, which is what I need for sine law. And so I can't do sine law, but I have side, angle, side, and therefore I need to use the cosine law. And precisely what I'm going to do is, because I need to find all angles and sides, by using side, angle, side, that's going to help me find the other side. So I am really finding the length B or line segment AC, as my first step. So my equation is b squared is equal to, the way I remember it, I go, okay, a squared plus c squared, I gotta add the other two. I have to subtract it by 2ab cos b. Let's plug it in. For line segment A, and my line segment A is this. My line segment A is 16 centimeters, so 16 bracket squared. My C is 25, so 25 squared minus 2, 16, 25. Cos angle is 97 degrees. As my next step, I end up getting 881 or so for this part. And I get about 97.49 for the rest. That has to do with the fact that cos of 97 at an obtuse angle is a negative. So overall, I'll get a positive with two negatives. I will get a positive number, 978.49. If I was to write this, I have b squared. I'm going to take the square root of both sides so that I get b is equal to 31.3 centimeters. Okay, so when you're asked to solve for each triangle, we are done this part. I have found my 31.3 centimeter. I still do have to find my angles, right? At this point, you should be saying, well, I know that I can't use the Pythagorean theorem, the SOHCAHTOA. We already considered that. Well, I could do the side, so one of the cosine law, to find one of the angles as my possible next step. Well, you can find any of the two angles. Let's say we find this one first. So you're going to say, well, we're going to find an angle like C, but you could have found the other one first. Keep in mind that your formula for, let's say, this is the following. And then you're going to start plugging in your numbers. So for my cos C, I had A is 16. I don't really need the brackets because my lengths are positive anyways. So 16 squared plus 31.3 squared minus 25 squared divided by the following. So I'm going to try to keep the exact numbers where possible. So I have cos C is equal to I'm going to rewrite the following. At this point, I want to get C by itself, so I'm going to cos inverse both sides, and therefore I will get C by itself. I'm not going to rewrite that part, so I'm just going to get C equals 53 degrees approximately. So once you found that part and we can say this is 53 degrees, well, you might be like, okay, I can do, let's say, cosine law again or something like that, or maybe sine law. But the easiest thing that you can do is do sum of angles in a triangle theorem, which just says that any triangle adds up to 180, and so the quickest way of finding the third degree is to add these two up and then subtract it by 180, or 180 minus 53 minus 37. So for angle A, we have 180 minus 53 minus 97. So angle A is equal to 30 degrees. Now, therefore, we have found all the angles. So question B, noticing right away it is a side example. Also, we can't tell whether it's a right angle triangle, and we can't assume that it is. So we have to assume that it's not a right angle triangle, and so we have to use cosine or sine law because there's no like little right angle sign. So according to sine, my equation that I have is cos A is equal to, I'm just going to start writing it in right away. So If I am solving for cos A, then I have to remember that I am looking for that, so I have to put that very last. So I'll just write the equation once. B squared plus C squared minus A squared, because that's the part I'm gonna subtract, and then divided by 2, not A, but 2BC. For my B value, sometimes it helps to write down what those are. So this is my B because that is opposite of the corresponding angle. That's C, that's A. So I have 18 for B, so 18 squared plus C is 21.9 squared, A is 10.4 squared, divided by 2, bracket 18, bracket 21.9. So when we work that out, on the top I have 695.42, on the bottom 788.4, and so what I have is cos A is equal to that. It's important you remember what's on the left side. Well, at this point I could cos inverse both sides, and so I will get my A value, and my A value is cos inverse of the number right here, which works out to be about 0.882. At this point, I'm not sure if you've ever taken cos inverse and sine inverse of a bunch of numbers. You're going to find that when you take cos inverse or sine inverse of a number 1 or less, you will get an answer. But if you try to take cos inverse or sine inverse of a number larger than 1, see what happens, but you should be getting an error. However, if you take inverse of tan inverse of a number higher than 1, you actually don't get an error. Just something to keep in mind, because in case for some reason you keep getting errors and you're like, what is going on? Algebraically, that's what's going on. So for this question, you get 28.1 degrees for angle A. So we can go back to our triangle and write this is going to be 28.1 degrees. That's not enough information, so there's a couple ways that you can solve for this. We still can't use SOHCAHTOA or Pythagorean theorem, although it's tempting because it's not a right angle triangle. There's a couple of things. Well, with side angle side, that's not really going to help me because that's going to help me find this side. And so I have to now use, I already used this part, the side. I said I can't use side angle side. Remember, I can use my sine law because if I know this angle and this side, then I could use, let's say, this side and find this angle. So really my only choice for my next step is to use side angle side. And so I have sine C divided by, sine C is the thing that I need to solve for, and the corresponding side I see is 21.9. We were talking about 28.1 and 10.4, so I have sine 28.1 degrees because that's the angle, divided by 10.4. If I want to solve for sine C, I need to cross multiply. So sometimes I use half cross multiplying, which means if I cross multiply, I'll get 21.9 sine 28.1 equals 10.4. I have to divide that 10.4 anyways. If you have no idea what I'm talking about, just do the full cross multiplying and you'll get to the same thing as what I have. You just don't want to make mistakes. You might as well do some extra steps, which if that means you're not making mistakes. So however way you do it, this is the this is what you should get to at some point. And as my final answer, I have to remember to take sine inverse of both sides. That way I can get C by itself. And so C is actually equal to about 82.7 degrees. Okay, so this looks amazing. We're all done, all done, all done, all done. But remember, we're dealing with sine law. Dealing with sine law, and what do we remember about sine law? Well, we should remember back here that something special happened with the sine law. Where is it? Sine law and right here. But wait, we have to do a check to make sure that is it the acute that we want or is it the obtuse that we want? Okay, so that's from the previous lesson. So take a look if you're unsure what I mean. So what I have to do is do a check. An angle C. So I don't know if it's hard to tell for you, but if you zoom in, that is larger than 90 degrees. So that is an obtuse angle. But 82.7 is not an obtuse angle. And so I'll quickly draw my cast, C-A-S-T. And basically, if my acute angle is 82.7 degrees, and that's basically my theta 1, well, this also has a related acute angle of 82.7 degrees. But if my theta 1 is equal to 82.7 degrees, my theta 2 is equal to, well, not 82.7, but the way I get it is by doing 180 minus 82.7, and that is for angle C. And when I do that, I get 97.3 degrees. Okay, and basically what I'm going to do is I'm going to unhighlight this part because that was actually not my final answer, but it's actually this part that satisfies the triangle. Basically, once we get to that point, we have 28.1. We have 97.3. An angle slightly higher than 90. It's an obtuse angle though. And then we can quickly find B by doing 180 minus 28.1 minus 97.3. And I get the following three angles. So angle A is equal to 28.1 degrees. Angle B is 54.6 degrees. Angle C is 97.3 degrees. As my final answers, like so.